So negative number in binary can be represented in two ways. One is 2's complement method, 2's complement, and other one is sign magnitude. So complement and other one is signed magnitude. So there are two ways to represent a negative number. Now let's say a 4-bit binary number representation. So we want to express, we know plus 3, we want to express minus 3 in both the ways, 2's complement and as well as sign magnitude representation. So plus 3 in terms of 4 bits will be 0 0 1 1, we know that, and we know the weights of each of the bits is like that. So this is 2 square, this is 2 cube, so this is basically 1 here, this is 2, this is 4, and this is 8. These are the weights, and this is positive 3. Now when we say 2's complement representation of negative number, that means the negative 3 will be just the 2's complement of the positive number. So if we can express the 2's complement of this one, that will be the negative 3. So the 2's complement of this one will be, the 1's complement will be just all the bits reverse, so inverted. So like that, this is 1's complement, and then plus 1, that will be 2's complement. So this will be 1101. This will be the 2's complement of will be the 2's complement representation of negative 3. Basically, when we are using 2's complement method, we are expressing negative 3 by this one. And we have to remember that the weight here will be like this, 2 to the power 1, 2 square, 2 cube, but this one will be negative 2, 2 0, 2 0, 2 1, 2 square, and negative 2 cube. So the weight here is negative 8. So negative 8, 4, 2, and 1. And when it is a negative number, this bit will always be 1. So this bit can be said that it's reserved for negative, and it will be 1 when it's negative number. So we can calculate the total number here. So this is a 1 here, this one, so that's a 1. This one is a 0, so it doesn't count. And then this one is 1, 2 square, so that's 4. And this one is a 1, so that will be, since this is negative weight, that will be negative 8. And we can see this one becomes 5 here, and then minus 5, so that's negative 3. So that is the negative 3 in terms of 2's complement representation. And when we say signed magnitude representation, that is a different way. So sign magnitude representation is, the positive is of course this one, but when it's sign magnitude representation of the negative number, it will have the most significant bit. Since it's a 4-bit representation, we are doing it all for 4-bit representation, the most significant bit will be reserved for the sign magnitude. So when the most significant bit is 0, that is a positive number, and when that is a 1, it's the negative number. So this will be 1, and the remaining number will stay the same. So it will be 1 0 1 1. So in case this particular case of 3, it has become similar, both are the same representation, but the method were different, because here we have just expressed number 3, and the most significant we have just placed a 1 because it's a negative 3, while in 2's complement representation we have actually calculated, found out what is the 2's complement of positive 3, and that is the negative 3. So we can do one more actually for the sake of practice. So basically, let's say we are doing 2, number 2, 1 0. So that will be, this is plus 2. If we want to express minus 2 in terms of 2's complement, so I'm just writing 2's complement here, that will be just the, since 4-bit representation again, that will be just the invert of this one. So invert on this one and then plus 1. So basically 2's complement. So this will be 1 0 1 1, and then we will add 1, so it will be 1 1 1 0. So that will be the negative 2 in terms of 2's complement representation, while in terms of sign magnitude representation we will write the same thing up to here, and then this bit will become 1. So that will be 1 here, 0, 1 0. So this is -2 in terms of sign magnitude representation, signed magnitude representation, while this one is the -2 for using 2's complement representation. And in this one, just the 2's complement one, we can again do the weight. So 2 to the power 0, 2 to the power 1, 2 square minus 2 cube. So this is -8, 4, 2 and 1. And we can see this one is 1 here, 1 here, 1 here. So -8 plus 4 plus 1. So that is becoming, sorry, plus 2 here because this is 2. So plus 2. So this is plus 6 here, -8, -2. So that's the -2 in terms of 2's complement representation. While in sign magnitude, we don't worry about the weight. We just place 1 here at the most significant bit because this is a negative number. And this one is just 2 here. So we are using just 3 bits to express the number. We cannot express more than -7. Basically less than -7. So